Hello again. In this session, we're going to introduce functions, specifically functions which are available to you when you open R, and then functions that you can bring into R using something we call packages. This is then going to set us up for the subsequent session where we're going to start building our own functions. So as we saw in the last session, we could use this C function to combine a whole bunch of numbers together into a vector. So for example, if I create a vector called England, which is a combination of the numbers 1, 2, 3 and 4, and run that, whenever I type in England, R knows that it represents numbers 1, 2, 3 and 4. And we know, and R knows, that this C represents a function because the C is followed by an open parenthesis. And it also knows that everything within the parentheses are elements of that function. Now, I could create another object called will, and I'm going to use a different function called seq, S-E-Q, which is going to generate a sequence for me. Now let's say we've never used SEQ before, we can pull up the help function, the help file for that function, simply by typing in $SEQ. And the help file pops up here on the bottom right. So let's quickly go through this help file, and what we have at the top is the name of the function and the package it's in, and the base package is what is automatically loaded when you open R. They're going to have a brief description of the function and then how we use it, and importantly the arguments that go within these parentheses. So what it's telling us here is if we want to build a sequence of numbers, we need an element called from, which is our starting point. So let's say we want to generate a sequence from 1 to 10. We're going to have from equals 1, 2 equals 10, and let's do it in increments of 2, which is dictated by this by argument. So let's do by equals 2, run that, which tells us that we've now got a sequence from 1 to 10 in increments of 2, i.e. 1, 3, 5, 7, 9. Now we don't actually need to type in the from, the to and the by each time, although it does make things very clear. Instead, we can simply just keep the order the same. So the first, for this seq function, the first number is always the from, the second number is always the to, and the third number is always the by. And we know this because it's of this bit in the help function. Now something I forgot to mention, which is very useful in these help files, is at the bottom there will often be examples of the usage of these functions, which can help you get a handle on what exactly it's doing. So let's run this win object again. And what we find, as we'd expect, is that it looks exactly the same as how we did it above. Now, one of the very powerful aspects of R is random number generator. So let's say we wanted to generate a large number of random normal variables. We can do this with the R norm. And let's say again we've never used that before. We can type in $R norm, which is in the stats package, which again is one of the ones downloaded or available when you open R. And here we can see our R norm, and the elements it requires, the arguments it requires, are the number we want to generate. So we're going to create a new object called fur. We're going to have, let's make 10,000 of them. So 10, 1, 2, 3. And we have a mean of 100. And a standard deviation of 10. Now, notice here that there are default values given to all of these functions. And what that is telling us is that if we do not supply one of these two arguments, either the mean or the standard deviation, R will assume it is this default value. Now, if we don't supply the n, that function won't actually work. Let's run it like this. And we have generated, let's type it down here. And what we have done is we have generated 10,000 values incredibly quickly, which are random normally distributed with a mean of 100 and a standard deviation of 10. Now, in fact, let's just do it again, but let's do 10 million, just to illustrate how quickly R can operate. 1, 10, 1, 2, 3, 4, 5, 6. Mean equals 100, and we'll keep the standard deviation as default. Therefore, R will assume it is 1. Run that. And again, very, very quick to generate 10 million values, which is really remarkable. Finally, let's generate a random exponential distribution of 1,000,000 values, and the elements that go into that are simply the rate. The rate of 0.1. Run that. There we have it. Now we can look at the distribution we've generated using the hist command, hist function. Let's create that. Or the first element is the values we'd like a histogram of, in this case cup. And there are many arguments which go into hist, which again we could look at using the question mark hist to pull up the help file. I'm just going to make it red for now. Hit run, and as you see, we'd get your expected exponential distribution with it's going to have a mean of 1 over 0.1, so of 10, which is what you see here. Now, hist, rexp, rnorm, seq, and c, these are all examples of functions that are available to us when we open R. Now, one of the great things about R is that it's open source. What this means is that anybody, you, me, anyone from all around the world, can create and share functions. These external functions are grouped into something called packages. And the most important source of packages is CRAN, which we can access through this tab here. What I'm going to do now is install a package which we're going to use quite a lot throughout this course, and that's called the DESolve. So I'm going to type in DESolve. Note it's a capital S, this one here. What this install dependencies box is all about is that many packages themselves rely on other packages, and keeping this checked just ensures that all those packages are installed at the same time. Let's click install. Now what may pop up on your computer is a window asking for which mirror to use. All that's saying is where which server to use, and it really, normally doesn't matter which ones are used. Typically the ones any within the US work well. Now what we've done here is we've installed a package called DESolve, and one of the functions which we're going to use a lot throughout this course is ODE, or ordinary differential equations. Now we can't actually access those functions yet, because all we've done is install the package on our computer, but we now need to bring it into this R session, and we do that using the library command. So we simply do library, type in the name of the package, and run that. Don't worry about this, this is just because I haven't updated my R recently. So we now have the DESolve library loaded in this R session. Now every single time you start a new R session, you're going to have to type this in, library DESolve. The install.packages we did, you only need to do the once, or maybe any time the package itself is updated by the developers. So this function ODE should now be available to us, and we can check this by seeing if the help file is there. And indeed it is. So here we have our ODE within the package DESolve, and this help file is going to tell us a little bit how to use that function. So that concludes the session on introducing functions. Next we will look at building our own functions.